Hello, welcome back. In this part, we're going to look more on defining function. This time, we're going to look at defining a function with variable number of arguments. Remember earlier we have the double the function or square function. We only allow one parameter, one argument. In this part, we're going to have variable number of arguments, meaning we don't predefine it, we allow it to have multiples. So let's look at a couple of these options here. We can start with default argument values. This is the most useful form, or it's quite useful to specify a default value for one or more arguments. So by default, there is actually already a defined value to go with it. This creates a function that can be called with fewer arguments than it is defined to allow. So let's just say define car underscore color, and we have defined that the color and the default value is red. So if let's define this, or define this function. So if I don't provide any color, and I'm going to get the car color as red, because that's the default value. What happens if I override the color is equal to blue, and I will get the car color being blue. So that's basically the key idea here. So note that the default values are evaluated at the point of function definition in defining scope. Okay, so this is only true at the point of definition. Alright, so let's just give you more examples so that you can understand what I mean here. What does this mean here? My color is equal to green. So define the watercolor and print the argument is equal to my color, which is green. Okay, print the arg, which is the argument. It should be green, that's the default color. So if I put my color is equal to orange and I run the watercolor, what happened? You would have thought that you change the my color to orange, this will actually change to orange, but it doesn't. Okay, it doesn't because the argument, this is only looked at, or this my color is only accessed at the time that the function is defined. So it's evaluated at the point of function definition. So at the point of function definition, the color or my color is green. So this default to green, it will stay green. Doesn't matter what value you put in under my color, it will stay green forever until you destroy the definition or redefine it again. So the important warning here is this: the default value is evaluated only once. Okay, this makes a difference when the default is a mutable object, such as list, dictionary, or instances of most classes. For example, the following function accumulates the arguments passed to it on a subsequent calls. Okay, so we have defined a function a comma L is equal to an empty list, and L append A and return A. So let's print this. What do you have? You have print F1. Okay, and then you print F2. Remember, L is defined as an empty list at the beginning. And what you get here is that because this is only an empty list at the point of definition, what you get is that next time when you run it, it will not be empty again. The next time when you run it, it will not be empty again. It will not be an empty list. It will just get longer and longer and longer. And that can become a problem when you actually define it this way, and that's especially if that is not your intended consequence. So if you don't want the default to be shared between subsequent calls, you can write the function like this instead. Okay, define F, A is the input, and L is by default none. If it is none, okay, if L is actually a test, basically equals to none, L is equal to an empty list. Okay, none and empty list is a very different. Empty list, it's that you define this data type to be a list. None is a data type on its own, which is none. Okay, so if the first time that when you define this function, if it is none, then we create L becomes an empty list, and we append append A to L. If, however, the next time that you run it, L is not none, then what would happen? It would just append to it. Okay? because L is by default none, this line, this if line, will always, almost always, gonna be called. Okay, so that's why they will be all standalone numbers by themselves. So let's move on now a little bit on keyword arguments. Functions can also be called using keyword arguments of the form kwalk. Keyword arguments equal to value. For instance, the following function define parrot A, B is equal to plant, C is equal to cat, D is equal to red. So let's run this. Okay, so we've defined a function. Printing the first argument is A, printing animals versus B, which is plant, print computer vision, comparing dogs versus C, cat, and then finally print the sky is red. So what it does here is that because B, C, and D is already predefined with the default value, okay, they become optional arguments. A, however, is compulsory. Okay, it's a required argument. So now you can actually just provide one value. Okay, so when you actually print parrot 100, meaning A becomes 100. What you will have is the first argument is 100, animal versus plant, computer vision, on and on it goes. And when A is equal to 2, then what you're doing here is that you have one keyword argument, okay, which also works just fine. If you have parrot, keyword argument, A is equal to 9, B is equal to bacteria, now you have just modified the default value of B from plant to bacteria. So the first argument is 9, animals versus bacteria. Alright, so now if you put C is equal to pet, A is equal to purple, that's fine because you're using keyword arguments, although positionally they are kind of like all over the place. But it's okay because you used keyword argument. Okay, so it knows that A being, because A is equal to, it doesn't actually matter which position it comes in. Now if you put parrot 1, 2, 3 like this, it's positional, that's also fine. It will take A is equal to 1, B is equal to 2, C is equal to 3. Okay, so when we run that, 1, 2, 3, and because we didn't actually provide an input value for D, D stay as red. And if you put parent, this first will be a headache, D is equal to biscuit, then that's fine. This will be a positional argument, this will become the keyword argument. Okay, so the first is headache, the last has been changed to biscuit. Okay, the rest remain the same. Now what's left with all of these will be invalid because remember we have a compulsory argument, which is the first one. When you don't put anything, you're going to get an error. This is what it looks like. Missing one required positional argument. Okay, if you put A is equal to 6 and then a what? Okay, the computer is gonna, this program is gonna get confused. Python will be like, okay, I see that you put a keyword argument for A, but what about what? What is the second one? But you didn't actually equal to anything, so it's gonna get confused. And again, it's gonna tell you positional argument follows a keyword argument. No good. All right, so this is the first, but A is also the first, and you get duplicate value error. And again. Okay, so parrot movie is equal to La La Land, and well, we have A, B, C, D. We do not have movie as a keyword argument. You're gonna get an error. Got an unexpected keyword argument, movie. So by now you are really an expert and masters in understanding errors. You have type error, you have syntax error. By now, next time when you come across this kind of error thrown at you, hopefully you understand what they mean. Alright, in a function call, keywords argument must follow the positional arguments. This part is really, really important. So let's just highlight this. No argument may receive a value more than once. That's also another key point here. Okay, so when a final formal parameter of the form star name is present, it receives a dictionary containing all keyword arguments except for those corresponding to a formal parameter. This may be combined to a formal parameter of the form star name, which receives tuple containing the positional arguments beyond the formal parameter list. Star name must occur before the star name. Okay, star name receives dictionary. Star name receives a tuple. Okay, I know that we haven't explained what is dictionary, what's tuple, but it's okay. All right, we won't worry too much about that. But for now, just look at this and understand how it works. So you have a definition here, long list. Don't worry about what all of these does. You have fruit, and you have the star tropic. Remember star tropic, or with the star in front, it gives the tuple. Double star, it's a dictionary. So let's just, where's our tuple? And then we have a dictionary. Okay. Okay, so because it's variable in length, okay, we do not know how long this is. So we kind of have to actually unpack it a little bit. So this is why we have this for T in tropic T. We loop over to tropic. Tropic is this input here. This happens to be a dictionary, so it's iterable, so you can actually loop through the whole thing. And temperature is our second one, which happens to be, sorry, this first one is actually a tuple. Tuple is also iterable, so we can actually loop through that, that's fine. We can also loop through the so-called dictionary as well. In this case, because dictionary is a key with the colon followed by the actual value itself, which is why it's displayed this way. So let's just run this. Okay, first one will be fruit. Okay, so that's the first, followed by banana, mango, and then you have two keyword arguments here. Now with this, it learns because the first one is actually a tuple. The second one, because it comes with keywords, notice that containing all keyword arguments, tuple containing the positional arguments. Okay, so this part is also very important. You must read the definition. Okay, so, and then we have the positional. And hence we have, this is the keyword, okay, which is the first one, which goes with the fruit. Fruit, just two, okay, print fruit, which is that fruit, print 40 times star, this is just a breakaway. Print information, this is star tropic, these are what's in star tropic, which is banana, mango, which is these two here, because we're using the for loop. Remember, these are the tuple, and they are positional arguments because we don't have a keyword in front of it, whereby these two have keywords. Australia is the keyword, US is the keyword, but we didn't predefine the keywords, so that's why it's double star is the two keywords, and this is in star temperature. Okay, and you get this Australia, orange, and US is Sunkist, whatever that means. Okay, I think we've covered a lot in this segment. We still have a little bit more to cover in terms of the arguments as well as the lambda expressions. Let's finish this, stop this for now, and we'll come back to those last two.